So here we are on TryHackMe's pre-security network fundamentals OSI model, layer 4, the transport layer. It's just to let you know, it's about 6:55 right now. I'm going to get all these done. We've got this one, and we've got 1, 2, 3, 4 more. So 5 in total. 5 videos in total. Also, just to let you know, I am drinking a beer right now. Also, just to let you know, I'm making these thumbnails fresh. Not that you need to know that. All right, so let's go. Layer 4 of the OSI model plays a vital part in transmitting data across the network and can be a little bit difficult to grasp. Nah, it's going to be fine. When data is sent between devices, it follows one of 2 different protocols that are decided based on several factors, either TCP or UDP. So we're going to begin with TCP, the Transmission Control Protocol. Potentially hinted by the name, this protocol is designed with reliability and guarantee in mind. Okay. This protocol reserves a constant connection between the 2 devices for the amount of time that it takes for the data to be sent and received. Okay. Not only this, but TCP incorporates error checking into its design, and error checking is how TCP can guarantee the data sent from the small chunks in this, in the sessions layer, which is the next layer we're going to talk about, has then been received and reassembled in the same order. Okay, we'll get into that. We're going to summarize the advantages and disadvantages of TCP in the table below. All right, so here are the advantages. First, it guarantees the accuracy of data. It's also capable of synchronizing 2 devices to prevent each other from being flooded with data. I'm sure there's a problem if that doesn't happen. And then it also performs a lot more processes for reliability. Okay. So the disadvantages of TCP are it requires a reliable connection between the 2 devices. If one small chunk of data is not received, then the entire chunk of data cannot be used. That's, this was probably more of a problem back in the day. Now with 5G and with, fiber optics pretty much everywhere, I don't think that's too big of a deal these days. All right. So a slow connection can bottleneck another device, as the connection will be reserved on the receiving computer the whole time. Yeah, again, 2025, I don't think that's a serious issue. TCP is significantly slower than UDP because more work has to be done by the devices using this protocol. But I mean, look at this. Look how fast this goes. Let's get up in Grok. That was nothing. Okay, we're still flying these days. All right, so let's go. TCP is used for situations such as file sharing, internet browsing, or sending an email. This usage is because these services require the data to be accurate and complete. There's no good having half a file. Like we just saw with Grok, it's got to be on the page. In the diagram below, we can see how a picture of a cat is broken down into small pieces of data known as packets from the web server, which is this thing right here, where the computer, which is this thing right here, reconstructs the picture of the cat into the correct order. Pardon me. Yeah, so this sends the packets. It's going to send the bottom part, the middle part, and the head of the cat. And of course, it's just going to be zeros and ones, and then the zeros and one. The computer knows that the zeros and ones means, okay, this pixel goes here, blah 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 blah. And so this computer is building the blueprints that this thing's saying, basically. But yeah, that's basically how that's going on. So now we're going to move on to the user datagram protocol, user datagram protocol, or UDP for short. Okay. So this protocol is not nearly as advanced as its brother, the TCP protocol. It doesn't boast the many features offered by TCP, such as error checking and reliability. In fact, any data that gets sent via UDP is sent to the computer whether it gets there or not. There is no synchronization between the 2 devices or guarantee. Just hope for the best and fingers crossed. So while this sounds disadvantageous, it does have its merits, which are going to be laid out in the table below, right? So here's the advantages of UDP. UDP is much faster than TCP. And that's definitely a thing. That's definitely a thing we like. UDP leaves the application layer or user software to decide if there is any control over how quickly packets are sent. Okay. UDP does not reserve a continuous connection on a device as TCP does. All right. So we've got disadvantages of UDP. UDP doesn't care if the data is received. That's probably a disadvantage. But it is quite flexible to software developers in this sense. I think this probably belonged over here, but whatever. This means that unstable connections result in a terrible experience for the user. Yeah, like I said, it's 2025. The unstable connections are a thing in the past for the most part. So using the same example as before, we can now see that only packets 1 and 3 have been received by the computer, meaning that a third of the images are missing. The third of the image is missing, right? So yeah, this cat's missing its midsection right there. Whatever. So UDP is useful in situations where there are small pieces, of data being sent. For example, protocols used for discovering devices like ARP and DHCP that we discussed in Intro to LAN, or larger files such as video streaming like we're doing right now, where it's okay if some parts of the video is pixelated. Pixels are just lost pieces of data, right? So yeah, as we speak, UDP is going on as I speak and as you listen. No, I'm kidding. This is UDP right here. And then when the site itself loads up, that's using TCP. So like we've got this under control. We know when to use this and we know when to use this. No big deal. All right, so let's go to the questions. So what's the name of this layer? Transport. Yes. Let's do it. Transport. Submit it. All right. TCP something protocol. Transportation transmission control protocol, of course. So let's do that. Transmission control protocol. Submit it. Looks great. All right. So what does UDP stand for? User Datagram Protocol. Let's do that. User Datagram Protocol. I said that word like 3 times. I better remember it. All right, there we go. So what protocol guarantees the accuracy of data? We know that's TCP. All right. What protocol doesn't care if data is received or not? We know that's UDP. We know UDP doesn't care. All right. So what protocol would an application such as an email client use? Definitely TCP. What protocol would an application that downloads files use? Also TCP. That's not a P. All right. Hey, what's up with this? Okay, good. Was that some whack TCP right there? Was it missing its whatever? I don't know. Anyway, actually probably. So what protocol would an application that streams video use? UDP. Yes. Oh, honestly, I don't know. Is this TCP right here? I don't know. Is that why this was taking a while? Because the packets were missing or something? I don't know. Anyway, interesting food for thought. All right. So now we're on to layer 5 session, and we'll see you next time.